13.8, dividing radicals. Big important thing here is a simplified radical can't have a radical in the denominator. You cannot have the root of 5 down in the denominator. So to simplify it, you have to fix that. So you have to, it's kind of interesting because just like when you multiply, you can put them together or separate them. You can do the same thing with dividing radicals. You can put them over the top of each other. Once you do that, you can simplify inside the fraction. So, or inside the radical sign, you can simplify the fraction. So 5 goes into 45 9 times. So basically what we have is the root of 9 over 1, which is the root of 9. And the root of 9 is 3. So it works out nice in this case. Gives you a nice little easy answer. Doesn't always give you an easy answer though. Here, this bottom part right here, we want to get this to a perfect square. Well, you can. If you count by 12, 12, 24, 36. The first one you get to is 36. So what we can do is multiply the, we can multiply this times the root of 3, as long as you do it to the top, times the root of 3. Okay, you can do anything at the bottom as long as you do it at the top. It doesn't change its value, it just changes what it looks like. So up top you have negative 5 roots of 21, and on the bottom you have the root of 36. Well, 36 comes out as a 6, so you have negative 5 roots of 21 over 6. Whoops. 6. Goodness gracious, I got to figure out my pen here. That's your answer. So remember, no radical in the denominator. Alright, to be simplified, it has to be. Okay, here we got 12 over 8a cubed. Well, first thing you can do, this is in the same house, first thing you can do is you can go, well, 4 goes into 8 twice, goes into 12 3 times. So what we basically have is the root of 3 over 2a cubed. Okay, we got to get this bottom one to a perfect square. And the first perfect square that we would come to with 2 would be 4. So we got to multiply this in times the root of 2, and then here we got to get this a cubed to a perfect square. The first perfect square it is a to the 4th. So what times a cubed is a to the 4th? Well, 2a. So we got to multiply that times the root of 2a, and top times the root of 2a. So up top we get the root of 6a. On the bottom we get the root of 4a to the 4th. 4 comes out as a 2. A to the 4th comes out as an a squared. So you get the root of 6a over 2a squared. That's your answer. Now, you look here and you say, well, 2 goes into 6. Nope, it can't. If there were a 6 on the outside, yes, they're whole numbers, so you could cancel, but not in this case. Anytime you have something like this right here, this 2 minus roots of 3, which is a binomial, you can get rid of this root of 3 by multiplying by its conjugate. So the conjugate. The conjugate is this same thing except with the opposite sign. So we're going to multiply this times 2 plus the root of 3. And the bottom one times 2 plus the root of 3. It ends up being this down here. Alright, let me show you down here a little side note. 2 minus the root of 3 times 2 plus the root of 3. Remember we learned it yesterday that it's the FOIL method. So 2 times 2 is 4. 2 times negative roots of 3 is minus 2 roots of 3. negative, or 2 times positive root of 3 is plus 2 roots of 3. We get rid of the middle term. And then this last time, root of 3 times the negative root of 3 is negative root of 9. So it ends up the middle term drops out. You just get 4 minus the root of 9. Well, the root of 9 is 3, so you get 4 minus 3 gives you 1. So on the bottom, we got 1. On the top, this is distributive property. 3 times 2 is 6. 3 times 1 roots of 3 is 3 roots of 3. So we end up getting this as our answer. 6 plus 3 roots of 3 over 1, but it's just 6 plus 3 roots of 3.
Made with Doodlecast Pro.